Hi everyone, this is the Studio 8 review. First off, let me just quickly apologize for the delay in getting this recorded and posted. I was pretty sick the week before Thanksgiving, and then I actually lost my voice for a few days and had to rest. You can still actually kind of hear a little bit. I still don't have it 100% back, but I am feeling much better now, so I'm very sorry that I was not able to get this video posted before today, but I still wanted to make sure that I got it done. Hope everybody had a great Thanksgiving break, and we're going to go ahead and hop right into the studio. I've already got it loaded up in Eclipse, and so we start off by reading a couple descriptions about some some classes, about some objects. First, we see it says the date has a month, day, and year, and so those should be, indications that we've got some instance variables for these classes being specified. So if I come up here and think about, all right, I've got the month, I've got the day, and the year, and we have to assign types for those. Those are probably going to be ints for each one. And then we've already spoken about this in prior videos, but instance variables of our classes are also going to be marked private. So that is something that I would expect to see here as well. Okay, and these are the hasas. Anytime you see that phrase hasa, that should be a pretty big clue that we're about to tell you some instance variables that are coming your way. For time, we see that it has an hour and a minute. So, and then we also have a field in time that indicates whether it be shown in 12 or 24-hour format. So let's go ahead and switch over to the time class and start incorporating those instance variables. We've got probably a private int hour, right? Private int minute. And then for the time, whether it's shown in 12 or 24-hour format, I'd probably say that's a Boolean, right? Boolean, 12-hour format or something like that, right? Although it won't let me start it with the number, so I have to switch that out for something else. 12. There we go. That's better. 12-hour format. So if this is true, we're going to show it in the 12-hour format. If it's false, we move it to the 24-hour format. That's the idea there. Okay. Let's see what's next. Okay, we can assume that only legitimate input values are given. That's good, so we don't have to worry about checking the numbers to see if they're appropriate values or not. And now we're going to make our constructors. So let's go ahead and make a constructor for the time object. Go ahead and do that first. Recall that the constructor takes a specific format. It's the name of the class or the object, and then we have to decide what the parameters are going to be. In this particular case, I think all three of our instance variables are going to be taken in as parameters here. And in traditional style, we'll go ahead and set these input parameters to our, whoops, I misspelled that, didn't I? Okay, so we've taken in these input parameters and stored them. We did ask you to think, though, what actually captures the essence of this. Notice that I'm assuming that all of these are stored in 24-hour time. In other words, the hour is going to be the same, whether it's stored as, whether it's actually shown to you as 12 or 24 hours is more just an issue of how we display the information. It's not actually related to the information itself. It's really just the hour and the minute that truly tell me what time it is. This is more just about formatting, how we wish that to be displayed, if that makes sense. I think it'll make a little bit more sense once we move on to the next step. So we see here that it does ask us to create java.comments. I'll go ahead and show how to do this once, although I think we should also go over and make the constructor for the date class as well. So let's switch over to the date class and do the same thing. In this case, we'll take in our 3 instance variables as well. I want to make it clear too that while I am very clearly taking in 3 parameters to set our 3 instance variables, that may not always be the case. While it is 100% true that the role of the constructor is to make sure that all of our instance variables have proper values when the object is created, those values do not necessarily have to come in as parameters to the constructor. For example, if I knew for a fact that every date that I wanted to create was going to be for this year, I could hard code this, right, and take this parameter off. This does restrict me quite significantly. I'm now only able to create dates that are, within the year 2022. Probably not what I want. Certainly not very useful, but coding-wise is certainly something that we can do, even if it may not be the best idea. To make things more useful, we can decide to introduce them as a parameter. Sometimes, though, it may be useful to have a hard-coded value that doesn't take in its value as a parameter. So that's possible as well. Okay, now that we've got constructors for both of our objects, what we're going to take a look at next is the Javadoc comments. All right, so here we go, Javadoc comments. So the way that we can set this up is by going above the constructor. I'll start with the time constructor here and typing /**. And then if I hit the return key, you'll see that it sets this up for me with the parameters for the 3 parameters that I have here. And here I'll make sure to make sure to include the information, right? That this is always a value between 0 to 24. Or maybe I'll say it like this: 0 to 23, I guess, right? And then between 0 and 59. Oops. And then this is whether the time should be displayed in 12-hour format, right? And then here, we would typically maybe provide a brief description of what this constructor is doing, if it's doing anything particularly unusual. Since this constructor is not doing anything particularly unusual, I'm actually not terribly opposed to just leaving this blank. You don't have to feel compelled to fill this in just because there's an empty line here. But you can put something here, right, if you want to. Right, there we go. Okay. I could go ahead and create that same thing for the date, but for the sake of time, I'm going to go ahead and, probably skip the Javadoc comments, most of them anyway. I might do a few more here and there. But just to kind of keep things moving along, I'm going to move on to the next step, which is to implement toString. Now, I believe I showed in a previous video how you can use Eclipse to do this for you. And, if you do this for the date class, it probably works out pretty well. If I come in here and the way to do this is to go to source and then generate toString. Which values do I want to include here? Probably these values, right? Month, day, and year. I can go ahead and click generate, and if we want to, we can then come down here and make a new date object for ourselves for today, which is going to be 11/28/2022, correct? And then if we go ahead and try to print this out, I would hope that it would give us a reasonable representation, month, day, year. There it is. I mean, this isn't quite the way that I would typically expect to see a date displayed, though, right? So what we may wish to do instead is something a little bit more traditional, where we have it as something like month / with a slash in between, or a hyphen. So this is where, creating your own toString or generating the toString and then kind of tweaking it a little bit can be an interesting way to go. Here we go. That looks a little bit more traditional, right? More traditional way of displaying the date just by modifying our toString. Might have been easier to just write that out. In fact, I think for the time, I'm going to go ahead and create the toString directly for that reason, because the time's a little bit more complicated. I have two ways to display it depending on what this value is. So here I'm going to return a string. I'm gonna need an if statement, right? If it's in a 12-hour format, I'm gonna return. And so this is maybe a little bit tricky, but if the hour is greater than 12, I need to subtract 12 from it. That leads some people to put a second if statement here, but that's actually not necessary. What we can do instead is say this.hour mod 12, right? So if it's bigger than 12, it'll give us the remainder. If it's less than 12, it'll just give us whatever that value is. Plus, and then we would probably put a colon in between, right, for the time, plus this.minute. Otherwise, we don't need the whole modulus business, right? We can just do the hour and the minute directly. Okay, let's try this out. I think we're going to need to construct a couple of different. So here's one for 1:22, which is what time it is right now, would be 13:22, and then I'll do one as a 12-hour format, and then I'll do another one as a 24-hour format. We can hopefully see the difference between the two. Okay, so I've created two different instances of my time object. One that they're both actually the same time, right? 1:22 p.m. One of them represents the 12-hour representation. One represents the 24-hour representation. So let's go ahead and run this and see what happens. I can see here I've got 1:22, that's my 12-hour representation, and then for my 24-hour representation it just says 13:22. I actually don't like the spaces in there after all. I think it looked fine for the dates, but for the time it just looks weird, so take those out. Including AM or PM would also be possible. That would take a little bit more work. We didn't ask you to do that though, right? We just asked you to display what time it is. I believe it doesn't make any mention of AM or PM, right? But if you wanted to, I certainly wouldn't be opposed to you doing that. So we just did step 4, and now we're going to go on and move on to the next part, where we're going to determine whether times are equal to each other or not. So, or dates and times for that matter, both of our objects. So if I switch back, let's start with our dates. Typically I would allow Eclipse to do this. So just like I did for toString, I'm going to start by right-clicking and going down to source, and then generating hash code and equals. These two always come together as a pair. Hash code, just as a brief little reminder, is a way to take an object and convert it into a number. Quite literally take any instance of an object and just generate a number out of it, with the idea that if I have the same object, it should create the same number for me every single time. And then the equals method, which is what we're really the most interested in for today's purpose, takes a look at, again, the essence of our objects, and then tries to decide whether they're equal or not. So we're actually looking at the time object right now, and you can see our 3 instance variables are hour, minute, and whether it's in a 12-hour format. And my argument is, right, that the actual time itself does not depend on how it's displayed. Right? 1:22 p.m. is equal to 13:22 p.m. in terms of whether they refer to the same moment in time. They do. They do, in fact, refer to the same moment in time. They're just shown to me a little bit differently, right? So the format that this is displayed in really doesn't affect what time it is, right? It's just how it's shown to me. So I'm going to leave this out. I'm going to uncheck that box, make sure that this is not used to determine whether 2 times are equal to each other. And so here we can see that it's generated a hash code method for me. So again, this is a way to take an object and convert it into a number. You'll learn more about this if you move on to take CSE131. For our purposes, we're more interested in this method right here. And actually, I don't even necessarily expect you to understand how everything in this method works. What I'm primarily interested in is the idea that if you look down here at the bottom, it's using the hour and the minute to compare to see whether these two objects are the same or not. It is not using the format. It is not using that 12-hour format. So if I come down here, for example, and I want to see if these two times are equal, I can say 12 dot equals 24. The answer will in fact be true. They are in fact equal. We have determined that even though one of these values does differ, that doesn't really matter. They still are referring to the same moment in time. And we've defined our equals method appropriately by leaving out the instance variables that do not really matter when determining equality. That's one of the big main takeaways here. If we switch over to our date now and run through the same process for this, we can go through and ask ourselves the same kind of question. I'm going to look at the source, hash code and equals. We now have the day, the month, and the year. I think it's pretty straightforward to understand that actually all three of these are necessary to determine a particular date, right? I don't necessarily know which date I'm talking about without all three of these pieces of information. So I'm going to leave all of them checked. I'm going to include all of them in my hash code and equals. Go ahead and generate that. We can see all three are used here in the equals method to determine equality. And so I'm not even feeling that compelled to test it out. I believe that it will in fact work as it is expected. Okay. So I hope that you took the time to read over some of this stuff about hash code and equals. We actually just did this entire part, in the code just now, so I'm not going to go through that in a whole lot more detail. What we're going to jump down and look at next is step number 7 down here. We're going to make some lists and sets to wrap up the studio for today. So starting with step number 7, I'm going to move to the date class, and I'm going to make a list of dates using this syntax. Actually, this syntax, while it will work, I believe is a little bit out of date. But let's go ahead and use it anyway. I can show you the difference. That wasn't an intentional pun, by the way, but here we can see I need to import this. In the prep work, you probably saw something that looked maybe a little bit more like this, a list of dates. This is a little bit nicer way to do it. In fact, we also don't even need to include, this is referred to as the parameterized type, this value in between the angle brackets. These are called angle brackets. So we don't actually even need to include this over here. This is another way of stating the exact same line, right? The exact same line of code that I had up here before. That's a little bit more modern, a little bit more up to date, a little bit more concise for that matter. But let's create a few more date objects. I'll create one for yesterday and tomorrow as well. So yesterday and tomorrow. So yesterday was the 27th, tomorrow is the 29th. And then I'll go ahead and add these dates into my list. Today. Tomorrow. Yesterday. Okay, there we go. So we've gone ahead and created the list with the angle bracket notation. It's definitely a good idea. If you haven't done so already, the prep work would have asked you to take a look at the API for the linked list and see what kinds of things we can do with it. I wouldn't expect you to be an expert of everything on this list. In fact, I have to be honest with you, there are some things on this list that I've never used before, never really thought about before, but there are some things on this list that I've used a bunch, including the one that I just showed you, the add method, which is one of the big things that we saw this week, was creating this list and adding things to it. A little bit later on, we'll see the other data structure, the set, and talk a little bit about the differences between the two of those. But for now, I've added some things to my list, and I'm going to go ahead and print it out and take a look at what happens. Here we go. Print out some dates. Here we can see my list of dates. You'll notice that they actually appear in the same order upon which I added them, right? Which is an important thing to keep in mind. Lists, much like arrays, have an order, so they do keep our elements within a particular order. Unlike arrays, lists are allowed to grow in size, or shrink in size for that matter. And the way that we interact with them is a little bit different than arrays, but they do have some similarities as well. Okay. Let's see what happens when we add two date objects to the list that equal each other. Okay, so I'm going to go ahead and create two dates that are equal to each other. I can do that by just making a copy of one of these lines, right? Naming this also today. So this is today. This is also today, right? I'll come down here and I'll add also today to the list. And I'll run this code again and see what happens. We see that my linked list actually has no problems whatsoever taking a look at taking both of those in, right? And including both of them on our list. That's not a problem for our linked list to do whatsoever, and it even maintains the order. We can see that today shows up twice, once at the beginning of the list and once at the end of the list. Okay. Now we're going to go ahead and use a set and try to do the same thing. So let's go ahead and make a hash set now and do something similar. I'm going to go ahead and make a set of dates, hash set. Here's the proper syntax for doing that. I'll need to import the set and the hash set. And then I can go ahead and add today, tomorrow, yesterday, oops, also today. And now if I come down here, instead of printing out my list, I print out my set. Let's take a look at what results we get back. Here we can see in my set, I actually only see 3 dates, even though I tried to add 4 dates. Right? Today, tomorrow, yesterday, and also today. It detected that since these 2 dates, also today and today, are actually the same, right? It's detected that since also today and today are actually the same, that it didn't need to include it again. So one of the big differences that we saw between lists and sets are that lists allow for duplicates, whereas sets do not. Sets also do not maintain order. You can see here that while I added today, tomorrow, and then yesterday, that it comes back as yesterday, today, and tomorrow. So the order of the elements is not maintained in a set either. So those are the 2 big differences between the 2 data structures. Okay? We're going to wrap up this studio with one final part down here regarding an appointment class. And this is an interesting little concept. Actually, I just thought of one additional thing that's pretty important to understand too, though, before we move on. If I come down here, notice that I have 2 objects here that represent today and also today. So I'm going to highlight those for a second and do a little bit more work on that before we move on to the appointment class, just to wrap this up. So if I look at these 2 objects, it is absolutely 100% true that today equals also today. They both represent the same date, correct? So we can see that that is in fact true. There's another way that we've used to check equality though. So if I typed it out differently, a little bit differently like this, I now see that this tells me that today does not equal also today, which is a little bit confusing. How could it be equals using one version of equality but not equals using another version of equality? So this is a very important concept to understand. When we're using dot equals, we're actually calling the equals method, looking at the instance variables and comparing them to see if they're the same. When we compare 2 objects using equals equals like this, we're asking ourselves, are these literally the same object? And so while these do represent the same date, we actually have 2 different objects here, right? 2 distinctly, uniquely different objects, today and also today. The way that we can tell is by this keyword new. Anytime you see this keyword new, I know that I'm creating a new instance of an object, as opposed to what sometimes happens is something that looks like this, right? Let's think about this situation. In this case, I also have two variables, today and also today, that refer to the same date. But in this case, there's only one date object here. I only see the word new appear once. There's only one date object here. Both today and also today are both referring to that same date object. That's an important concept to understand, because now we'll see that equals equals here does in fact return true. They are the same object. Dot equals would also return true for the reasons that we spoke about previously, but they are testing equality in two different ways, right? Dot equals is the more human version of equality. Do these two mean the same thing? Whereas equals equals is a more computer sciencey version of equality. Do these refer to the same object? Am I talking about, is this thing on the left side the exact same thing as the one on the right side? Or are they, if they're just two copies that look similar, that's not good enough. They need to be exactly the same. All right, let's move on to the last section regarding appointments. So I'm going to go ahead and make a new class here called an appointment class. And for this one, we can see that an appointment, so we have to design it ourselves. We have to think of the has-as, right? So an appointment has a, well, if you think about what you need for an appointment, it should come as no, oh, actually, I should have just read this line right here. It says it has a date and a time. So let's go ahead and think about that. This is, can be a little bit confusing, but we have classes called date and time that we can use for this purpose. So the capital letter date here is literally referring to this class, right? You might want to call it something else if it'll help you distinguish between the two, right? Appointment date, appointment time, okay? We're going to use our date and time objects as the type of our instance variables for our appointment object. So there's nothing wrong with this, right? Any class that I create can be used anywhere that I use any other type. So this is totally an okay thing to do. All right, we're going to go ahead and actually I'm going to go ahead and make a constructor first before I move on to the next step. It's simply going to take in a date and a time. And now I'll go ahead and use Eclipse to generate a new hash code and equals. This time I'll specify that I want the date and the time to both be included to determine an appointment. I believe both are necessary to determine whether an appointment is the same as another appointment or not. And what we want, this time, what we can see is that it delegates equality to the objects. In other words, if I come and take a look at the code here, there is a lot of code, but if you look down here, we can see that appointment date dot equals, that's the equals method that we had in our date class. And appointment time dot equals, that's the equals method that we had in our time class. So really, to determine if two appointments are equal, it's just a matter of using the equals method of the respective instance variables to determine if they are in fact equal. Just going to show why these methods are so important and why it's so important for us to define what equality means as programmers. If we define equality incorrectly in the date class, or I'm sorry, in the time class, for example, if we define equality incorrectly by including this instance variable, for example, it can have ripple effects. It can have effects. Okay. Going to go ahead and create a couple of appointments here and print them out just to wrap this section up. And then I think we're, one final design object here. All right, I am on appointment. I didn't create a toString yet, did I? Let's go ahead and do that. Using the same trick. So which parts do we want to include? I want to include the date and the time. Sure. Let's go ahead and generate that. Notice that by doing this, it'll actually be using the toString methods from these two as well, from these two classes as well. I'll make a new, actually I need to make new dates and times before I can make a new appointment now, correct? So 11/28/2022. Okay. The time is 13:41, and I'll use 12-hour time. A new appointment with today and now. Oops. And then finally, we'll go ahead and print out this object. There we go. We see that the date and time are taken in, right? The toString format of the appointment class is a little bit lacking. It's just the Eclipse auto-generated, but we do see the toString, right? For date here, we see the toString for time here being used. So this is a great example showing how we can use objects to build up a more complex system on top of each other. And then if we think about the final, thing here, a calendar object in terms of a collection of appointments. Should we use a list or a set? What methods should our calendar object offer? Let's go ahead and talk about this. This will be the final part of our studio for today. If I go ahead and make this calendar object here, we know that it's going to contain an appointment, but a calendar can contain lots of appointments. So if I think about my calendar, right, I have a whole bunch of appointments. In fact, I use an appointment tracking app online to help manage my appointments. Those of you who've come to meet with me have interacted with it on the Calendly website. For me, the order definitely does matter, right? I definitely do care about the order that the appointments are in. So that's something that very much matters to me. I think that's a strong argument for the case of a list. However, you could also argue that having duplicate appointments on my calendar is no good. I don't want to have 2 appointments at the same date and time. That would be very bad. So using a set for my calendar could also perhaps be a strong choice as well. And this is, I think, illustrative of one of the trickier parts of computer science. There may not always be a clear, correct choice. At some points in time, there might be more than one option that seems reasonable, and you may just have to pick. You may just have to pick and decide and go with one and see what happens. So maybe the order that the appointments appear in is something that really matters to you a whole lot. So you decide to go with a list, and I'm going to go with not a list of dates, but a list of appointments. I'm sorry. Right? Maybe the order doesn't matter to you so much, and you decide to go with the set. Maybe both choices are correct in different situations. That can totally be a thing. A list could be correct for one calendar app, and a set could be the correct choice for a different calendar app. So this is really, an interesting part of the studio where there's not necessarily a wrong answer. It boils down to, can you understand the difference between using a list and a set of appointments to track a calendar and make a choice. So if I make, there we go. Of course, mark it private. If I then wanted to actually start writing some code for this, I'm not going to flesh out the entire class, but I'll go ahead and get it started. In this particular case, here's a good example of when I create a calendar, right? I probably don't have any appointments in the calendar to start with, so I may not need any parameters here, and that's okay. I don't need to have parameters in my constructor. But it is still my responsibility to make sure that every single one of these instance variables has an appropriate value before the constructor is over. And if my instance variable is an object or a collection, like a linked list or a set, I need to construct that. Even if it's going to be an empty set or an empty linked list, it is still the role of the constructor to make sure that your list or set has been properly set up, so that later on the code that needs to access that collection can do so without running into problems. This is one of the most common errors that I see on assignment 8, for example, assignment 9. So the way that we would do that in this case would be to say this.calendar equals new, probably use a hash set, since that's the one that we've been speaking about. And that's really it. That's all we need to worry about. Of course, we need to import our hash set here to make that happy. And there we go. That's all that this constructor needs to do to make sure that this instance variable has been set up properly. From here, I'm almost certain that we would want a method to add appointments, right? So we would need to have, and in that particular case, I'd probably just pass that appointment directly into my calendar. This.calendar add a. Stick that right in the calendar. If I wanted to see if I have an appointment in there or not, right, I could check that. I could write a method to check that. And so these are probably what the calendar methods would look like. I think it would also be a good idea to set up a toString and an equals method for your calendar object. But because there are so many different directions that this calendar object can go in, I'm going to go ahead and stop here. I would love to talk to you about your calendar objects, about your appointment objects, but this is going to go ahead and wrap up the Studio 8 review. So thanks a lot, and I'll see you in class.